Welcome back everyone, and we're moving into part 8 now. We've covered a lot of ground on the select statement, so now we're going to show you how to use different methods to achieve results in your select statement. We're going to be looking at inline views and sub-selects in part 8, and as we are going to be covering quite a bit of ground yet again, we're going to break part 8 up into separate videos as well. So let's head on in to SQL Server Management Studio and begin the lesson. Okay then, first things first, as always, let's change that database to wide world imported, and we're ready to go for the lesson itself. Okay then, inline views, also known as derived tables or sub-selects, are another way of compiling, of putting together your select statement. They have their uses in certain scenarios. So we're going to look at these within joins themselves. So we have a look at this example on screen there. You'll see your standard select statement with a few inner joins, but then we get on our third inner join, we get what looks like another select statement. And that's pretty much all a sub-select is a select statement within your select statement. We start off by an open brackets there, and we close our sub-select with another round brackets, as you can see there, and then we just simply type out our select statement like we would normally do. Have as many joins as you want, etc., etc. So all this is doing is effectively creating data on the fly, creating its own little table for us to use within the remainder of the join. Now this piece is part of the inner query, and of course everything that you can see here is on the outside, so that's the outer part of the query there. So what are we trying to do with this sub-select then? Well, we're simply selecting the customer IDs. We're going to sum up the extended price within the invoice lines table to give us the total invoice value, and then we're going to also use the average command to get an average value of the extended price to give us our average invoice value. Now we're joining our invoices together and our invoice lines. Invoices is where we get our customer ID, and the invoice lines is where we get all the pricing information for us to do our sums and averages. Now if you're used to Excel, you've probably seen these same sort of functions in there. The sum or summary function simply just adds together all the values in that column. Average averages them out. And we've also got a filter here. So all we want to see is these figures based on invoices in the year 2015. So that's how we're going to filter those details off there. Now don't worry too much about these aggregate functions here. We'll be covering those on a later episode. Suffice to say, we're going to use these functions here, and because we've got a individual customer ID, we want to see all the customer IDs, we then have to do a group by in order to get that to work. If we don't do that and just select that and try to run it, as you can see it says invalid because it's not in the group by clause. So we need to tell SQL Server that for every customer ID we want to see the total amount of invoices, the values, and the average invoice value within the year 2015. So that's for each individual customer. Now the great thing about sub-select is if you want to check your code, simply highlight that, hit execute, and we'll see if it runs. So there's your results. You've got your customer ID, and you can see that in 2015 he was invoiced a total value of $132,182, I presume, and his average invoice value was $1,190. Don't worry too much about the additional decimal places coming through here. What we're mainly concerned about is the functionality of the code. So now that is for each customer. Because we've grouped it on each customer, we get separate values per customer depending on their total invoice value and their averages there. So we know that our subselect functions perfectly well, so we're happy with that. Now that we've built our subselect, we've placed it in a join, what we've got to then do is actually give it a name, because if we don't give it a name, as you can see, SQL Server doesn't know what to call it. How do we reference a subselect? How do we join it onto other tables, etc., etc.? So we have to give a subselect a pseudonym. In this case, I've given it A, and of course we're joining on the customer ID, which we have pulled here in our subselect, and we're joining it to the customers table here. So in effect, it's just like your inner join, except instead of pulling from an existing table within our database here on the left, we're actually creating our own little table with the subselect here. Give it a name, join it up, and there you have it. Pretty straightforward, pretty simple. So what we're going to be doing is we're going to be pulling all the customer IDs, invoice IDs and invoice dates from the invoices table. Then we're going to be pulling the line IDs, description and extended price from the invoice lines table. And after that, all we're going to be doing is showing the total invoice value and average invoice value against every single row, but as we're joining on the customer ID here, you'll see a different value pop up against different customer IDs. I've sorted it all so you can gain more of an understanding on that. Let's have a look at the results, and I'm sure things will make a little bit more sense. Here you go. So as you can see, our customer, number 1, customer ID 1, whoever that might be, placed quite a lot of orders in 2015. You've got your invoice ID, there you have 2 invoice IDs that are similar, so that tells me that there's 2 separate invoice lines. So we're going down from the customer level right down to the invoice level, and then further down, breaking things down into individual invoice lines. So customer ID 1, he had this invoice ID, there were 2 rows there because he bought 2 separate items, and he has the extended price for those specific items. So that's your data on a row by row level. And then obviously when we've joined our subselect, which is our total invoice value per customer and average invoice value per customer, you can see that it simply puts those 2 values against every single row in our table for customer 1. Now if we scroll down, try and get to customer 2, somewhere further down, here you go. You can see again, customer 2, he had 4 order lines for that, 4 invoice lines for that invoice ID. There were 4 different items ordered, hence the fact we had 4 lines. There's your price of each individual line, and then it simply puts the total against every single line for that customer. And you've got the average as well being brought in. So you can see the difference between customer 1, you've got these 2 values here, and then customer 2, you've got a different value. But all it's doing is simply putting the values in your subselect against every single row on the remainder of your statement there. Pretty straightforward stuff. And that's pretty much all that the subselect is about. However, there are some key things you need to know, a few pitfalls that you need to have to be aware of, just to make sure that you get the right data at the end of your query. So if we look at our code here, once we ran this off, we've got 228,000 rows and 41 at the end there. So there's quite a lot of rows going on for 2015. And if we look at our result set, you might have picked up something odd, in so much that we've got invoice dates here which are outside of 2015. So we had a filter here, 2015, we inner joined. So why are we seeing invoices from 2013 and so on? And that's because if you have a filter within your subselect, all it's going to be doing is filtering the results of that subselect. As you can see from the rest of our query, there is no where clause at the bottom here. So nothing's been filtered. So all it's doing is it will be pulling every customer, every invoice line within the entire database, and then it'll just be doing is bolting on these values to each customer ID, and this is where it's filtered the subselect. So what will happen now if we pull that one out and we put it instead on the outside query? So now what's going to happen is our invoice date on our invoices table here will be filtered on 2015. Let's have a look at those results quickly. We only have just shy of 72,000 rows, so it's quite a considerable difference. And you can see now that we have an invoice date of a year of 2015 for our entire result set. So we know that that's filtering correctly as well. However, there's a second issue here that you really need to be aware of, and that is if you look at the total invoice value, it's absolutely massive for customer 1, and the average invoice is pretty high. So those don't really align with the figures that we had previously, and that is because while we have placed a filter on the outer section of our select statement, there's no longer a filter in here. So all it's doing is taking the customer ID, taking every single extended price, no matter what the year is, making the sum and making the average, which is why those extended prices are absolutely huge. So how do we get around that? We simply make sure that we have a join in both select statements. So now we know that our subselect is filtered with the invoice date as 2015, and we know that the rest of our query, it's all being inner joined, so that filter will work across the board, restricting the rows there. So let's run that off. And as you can see, that value is a bit lower, pretty much what we saw in the first place, and we are only receiving data for invoices dated 2015. So that's one key thing for you to remember, is where you put your filtering, because this is a separate select statement to this one here. So you need to make sure that if you need to put a filter in both, then you do so, or you'll get some strange results. Now, what if we put a left join? How do things change there? We're going to remove that filter as well to just show you what's going on. And we get a slightly different result yet again. 265. That was 041 previously. If we scroll down our list, we can see some nulls creeping in. So that tells me that we have a few customers, 156, etc., who didn't actually order anything or didn't have anything invoiced in 2015. But because there's no filter on the outside, we're still pulling those values. You see there's an invoice date 2016, and there's no values from 2015. So because it's a left join, it's still pulling the rows, but then our aggregates, which we left joined on, our sub-select, there is no data to join on with. So we've ended up with nulls in there. So that's a few things to be aware of when you are bringing a sub-select. And again, these can be very useful within your queries to build up a little table on the fly, and make sure that you can then join that table with all your others using all the same methodology as you would do in a standard join, just making sure you put a round bracket before and after your sub-select. Make sense? Fantastic stuff. We'll move on with a few examples to really help you to understand the sub-select. So, firstly, the sales manager is keen to see roughly how much customers' orders, in value that is, are versus how much they are averaging in 2016. So you need to supply the customer's name, their total order value, and their average order value over the entire year. So we've got a similar query as the one above. Now, the first thing you'll know about this query is that it doesn't make much sense. It's a bit wishy-washy. We don't quite know what's going on. Fortunately, we know the columns that we need to select, given what we have here. Now, you'll quite often get requests like this from people who are probably not too sure what they want, or very good at explaining what they want. So, at any point when you work in a SQL environment and you get a request like this, where you're not too sure what's going on, just get back to the person and clarify 100% what they're after. So let's head on into the question itself. We'll go through it together. Start off with the select star as usual from, and the first thing we're after is the customer's name, and we know that comes from the customers table. So let's find where that is. Here we go, sales customers. Fantastic. So we brought that in, pseudonymize it as the usual C. Customer's name. And there we go, we've got that. So the next two columns that we need to bring in are, of course, we've got a total in there and we've got an average in there as well. So we're probably looking at something like the sub-select here. So what I'm going to do very quickly is simply grab that code there and let's have a look and see what's going on. So this was obviously all about invoices. What we've been asked for is total order value, so we'll just simply change these to orders as opposed to invoices. So might as well make your life easy, cut and paste code as you see fit to achieve what you want to achieve. Just that simple, right? We'll change what we need to change. Fortunately, SQL Server underlines everything in red. That's out of order where it can, which is very helpful. And of course, we're looking for values and averages within 2016. So we know that that's 2016. And if we look at orders, we of course have an order date. I'm sure you knew that from working with these tables anyway. So we're looking at an order date. Let's make sure our pseudonym is passed all the way through. There we go. Now, what we're after is the total order values, and the average order values there. Remember what we were being asked for, total order value and the average order value in 2016. So what are the values in here that we're looking for? Let's have a look at order lines, because that tends to keep all the values. And we've got a quantity, but we've been asked for the value, so it's probably the unit price. Now, he's ordered 50 of this item, and it's got a unit price of $112. So, what we're saying is that we need to multiply the quantity by the unit price to get the overall price of this entire line. So just pulling the unit price, which is a single unit price, is not enough because 50 units were ordered. So we have to multiply the two together, and we can simply put that within your brackets here that you're summing up. So we're looking at the quantity multiplied by the unit price. There we go. Close off our round brackets because the sum function requires an open and close bracket. So what it's going to do is it's going to multiply the quantity by the unit price for every row and then sum them up for every customer. And all we need to do is grab that, paste it in there, and we've got our average as well. So you can put mathematical formulas within these brackets here to manipulate them how you see fit. So that'll give us our total order value, that'll give us our average order value for every customer based in 2016, and we're going to group by, don't forget to group by when you're using these aggregate functions, by the customer ID. So for every customer ID we're getting their total order value and their average order value. So let's bring those in to our main code there. Total order value, and of course we've pseudonymized it as A, and that'll be our average order value. And that's it. Pretty simply, what we've done is we created very quickly our outside part with our select customer name from the customers as C, because obviously the customer name is basically a straight select off the table. We're not totaling or summing anything from the customer's table, so we're quite happy to build up our query very quickly to get that customer's name. Now, total order value and average order value per customer, we need to put it to some sort of subquery. We can do an inner join here or a left join, and that is pretty much it. We can put an order by. Let's do that so we can see the results. Order by the customer ID. In fact, we'll order by customer name. So of course, don't forget that you need to bring in the customer ID within your subselect here, within your bracket, in order to then join it outside of your subselect with your customers table there. All good? Let's run that off and see what we get. There you have it, our customer. That's their total order value for 2016. Did I do that correctly? Yeah, for 2016, for all their orders in 2016. And here's the average order value for all their orders placed in 2016. So that's some pretty straightforward subselects for you. There's that example done and dusted. If you're keen to try out some more examples, well, I've got just the homework question for you. Let's close that down. Let's put your skills to the test then. Right, this one is pretty straightforward. I've broken it down into steps to help you build up your query from there. So the question is, there appears to be a discrepancy between some of the stock on hand and the amount of items sold figures that no one can seem to explain why. You have been tasked to provide the customer service manager with a list of the stock transactions totals per item for 2016 against the actual stock on hand holdings. So your first step then is to write a query to extract the following stock item ID and the total stock transaction quantities for each one of those stock item IDs from the stock item transactions table. So we're only working on one table here for your sub-select. Make sure you put in the right filters using the year function, etc. And of course, to calculate the total figures, follow the same logic as the sum functions above. Not forgetting your group by. Highlight and test your code, make sure it's working before moving on to part 2. Right, step 2 then. Using this code as a sub-select in another select statement, you need to bring in the stock item name, which is of course from the stock items table, and the on-hand quantity, which is from the stock items holdings table. So at the end of it, for all the stock edits carried out in 2016, that's maybe another filter you need to consider, you end up with the following columns in the final results. So stock item name, total stock transaction quantity for each item based on transactions in 2016, and the on-hand quantity as well based on all stock take edits carried out in 2016. So that's another filter you need to look out for on that data there. Now you can rename your column as you see fit, and the answer will be in the next video. So everyone, give that one a try. We'll have a look at it in the next video, and I hope to see you all there. Everyone, I wish you all a fantastic day.